Samsung Apple lines are 13
Oh, Jesus.
You're on the air.
Need that. Yes.
All right, I guess we'll call the meeting to order. The old meeting organizer presidents like to say anything before we start?
We've been here long enough, good enough, go ahead.
Okay. For those who don't know me, my name is Chris Hotchkiss. I've been coming to SLUG for some number over a decade years. I don't remember anymore. I'm not gonna calculate it right now. This presentation is on a pet thing that I monitor at work for when we have to implement it, IPv6, and how it affects you. So, to get started, so the first thing to ask is, well, depending how technical you are, how much you deal with the networking side, A, what's IP, and what the heck's IPv6? So for those that don't know, in your classic network stack, you have your hardware level, your link local. This consists of your Ethernet network, the cable you plug into the wall. And then on top of that, you have two more layers. One is IP, and the other is something like TCP or UDP. So from the perspective of the layer above, it doesn't have to care about the layer below, and vice versa. Now, IP ends up acting like a phone book. So when you say, I want to go to a specific IP address, so give a comment to, so a common couple that you've probably seen in your days at home or doing stuff at work, 127 or 192.168. This is a classic IPv4 address. It says, I want to reach this host on the network, and the network equipment's job by its routers and switches to route you there. And that's classic IP version 4. It's been around for at least 30 years now, 35 years. But there's a problem. So this address here, when you get down to the actual packet level, is 4 bytes. So each one of those dots is a hexadecimal value of 8 bits. And if you can read my handwriting, all the power to you. That ends up being, on the math side, 2 to the 32 addresses, or about 4.3 billion addresses, which at this point in time, we're running out of. There are so many devices on the internet, and in the past, allocation of addresses has been so poor that it just can't keep up. And in parts of the world, and I'll go into a little more detail about that, you just can't get an IP address anymore.
They stopped issuing them. They already went through the last bunch, right?
Well, I'll get to that in a second. Actually, I'll do it right now because it segues nicely. So today, if you want to get an IP address, and you're just an end user, you go to your ISP and say, I need a set of IP addresses because I want to run these servers, I want to support these clients. But where do they get them from? There's a nice hierarchy of organizations that manage and distribute out these IP addresses. The granddaddy of them all is an organization called Internet Addressing and Numbering Authority, and it has 5 what are called regional authorities, and it spreads out across the globe. There's one for Africa, there's one for Asia Pacific, there's one for Europe, North America, and South America. Now, because of the reduction in numbers, the exhaustion referring to was that these numbers, because there's so many, are allocated in what are called blocks. So there are, IANA had 256 blocks to give out, and that was a slice up of every single IP address available in the world. They've since given out all those numbers, and they're not available anymore. So if one of these 5 needs more numbers, there's no place else to go. And in fact, they each maintain their own pools of numbers. 2, Asia Pacific and Europe have run out of all of their numbers as well. So if you're in the Asian continent and you want an IP address, there's just no more to get. So the solution that was dreamed up about 20 years ago was what's called IPv6. So what IPv6 is it takes this 2 to 32 number and quadruples it. Well, way more than that. It's 2 to the 128th. So it took the addressing of what's an IPv4 packet and added 12 more bytes of data onto it. This results in an absurdly large number of possible addresses. And the nice thing about this number, 2 to the 128th, let's say you wanted to count through it, you would elapse several 100 trillion times the age of the universe before you finish. And it would also cost you an immeasurable amount of energy. So we have a bunch of numbers now, but there's a big problem. And that problem is all this existing equipment that's out there and working just fine. And that's actually what we're going through today. So because these 2 regional registrars don't have any more IP addresses, there's an ongoing movement, and you may have seen it in the news, called World IPv6 Launch Day or Prep Day. One happened last year, and it also happened the year before that. That's when all the big companies of the world got together and said, we're going to turn it on and prove that it actually works. Because before that, it was a nice little chicken and egg problem of, well, there's nobody out there wanting an IP address, so why should I serve content to them? So both of those launch events were, and I'll show some of the graphics and stuff, what they came up with, were to turn on IPv6 for major websites. So for example,
So, sorry, one quick question. Is there an ISP in Tampa that supports IPv6?
yes, there is. Verizon Wireless.
No, they don't.
Yes, they do. If you have a 4G Verizon Wireless device, you have an IPv6 address. And 30% of Verizon Wireless
BIOS?
Unless you have this.
Hmm?
Unless you happen to have I forget the model number.
Yeah, the device doesn't.
Yeah, the device doesn't, but your 4G cell phone does.
Yeah, but see, that's Verizon Wireless, separate company from Verizon.
That's correct.
Because I know FiOS does not, and
Bright House does not either.
exactly.
Now, one of the things I will go over is how to get it yourself, even though your ISP is behind the times and lies to you if you ask them if they support IPv6, which Bright House loves to do. I ask them every year just for kicks.
And they say yes?
They say it's under testing. It'll be ready in a couple of months. I've asked them that 3 times over the past 3 years.
Despite the fact that they haven't even allocated, they haven't done anything with their blocks.
Correct. However, they have started upgrading their modems to the new cable DOCSIS 3, which will support it if they ever turn it on. Their older modems just wouldn't.
Verizon started the first IPv6 network, though. So I would think that they...
Also, T-Mobile,
You're lying to yourself.
T-Mobile has had IPv6 for a couple of years now.
William can give you plenty of cynicism on the Verizon side if you would be happy to hear it.
My name's Zach William. I have no idea what you're talking about.
There's not a camera line.
Is what it is. Conversion. So there was actually a big debate going on about 2 or 3 years ago about what the future of the internet was going to be.
Cybernetics.
Cybernet.
So at the time, we had IPv4, we're almost out of addresses, and we had 2 possible paths that we might have ended up on. One was IPv6, and then the other one, which certain countries seem to be wanting to go towards, is called carrier grade NAT, where today, if you have a normal home network, you'll have your ISP. They give you a single IP address typically nowadays because nobody wants to pay for more. So at home, you have your nice little router, and all your devices sit behind a nice NAT device. So you have your NAT, and your one IP address becomes many for all your devices. Now with carrier grade NAT, your ISP also runs their own NAT box for you. So your one address is actually shared amongst a bunch of different customers, and you have no way to control that. So what ends up happening is certain applications, ports, and protocols start to break because of the double NATing. So that was actually one direction the internet could have gone in a few years ago, if things had turned out a little bit differently.
That is actually used here. T-Mobile uses it on their IPv4
Yes.
network, and some other,
Well,
right now
there's-
uses it sometimes.
So what ends up getting implemented? Well, the danger is that carrier grade NAT was going to be the only thing that got implemented. What's actually ending up happening is, now we're in America, so we still have tons of IP addresses left over. But they're still implementing carrier grade NAT and IPv6 at the same time. So you'll get your v4 address. It may or may not work depending on the application, and they're hoping that you'll switch over to IPv6 quickly. It's luck of the draw, though. With the V6, the carrier grade NAT, normal end user has no idea what's going on. It's way too low level, and they don't care. But it's the danger that you run into, especially if you run an internet-facing company, is, so today, most people have a v4 and a v4 address. Some have both v4 and v6. But the danger is if you have a global company, that, especially in the Asia region, you're going to start seeing v6 only clients start to show up on the internet.
Is there going to be a time period when you would have to be using both personally to get full functionality? You were saying
Yes.
the carrier grade NAT won't pull everything off quite, but then there might be services that only would work on the carrier grade NAT and haven't switched over to IPv6.
Yes, sites that are not switched over to IPv6, like /dot and I think Reddit. Well, Reddit might be fixed. There's a couple other large sites that are still IPv4
Are they
only.
doing anything to expedite the process?
Well, it's what most of this is tied to. So this is on the software side, whether or not you can reach it. On the hardware side, if you use a network hardware, and I'm talking big network hardware like Cisco equipment, your IPv4 with your big switches and routers is all done in hardware. So all that routing has special chips in it that tell the packets where to go in a router on the given network. What happens is when you enable on older Cisco hardware IPv6, that doesn't have a dedicated chip for it. So it gets done in software. Your router overheats and crashes. So to go to both IPv4 and IPv6, everybody's having to replace all their network gear. So that's nice.
It's about time they upgrade anyways. You said 20 years ago.
Because they have to update all their hardware and it's expensive, it's getting tied to refresh cycles.
So first they tried to write software into the system. They tried to flash the Cisco equipment with software that would pull it off, and then that took far too many cycles too quickly, and it was said burn up and no more.
No, it will support IPv6, but if you get more than 5% load on that router, the CPU is going to max to 100%, and you're not going to get your nice $100,000 worth of equipment out of it. Now, as cycles get refreshed, an interesting thing about IPv4 versus IPv6, IPv6 is actually easier to route and write hardware for because there's less overhead in processing an IPv6 packet compared to an IPv4. Because in IPv4, the header of every packet has a checksum on it that switches and routers are required to validate. So these fancy hardware implementations basically do that all on hardware. It's fast, but it limits the speed of your router because you still have to run the calculation. V6, that goes away. And as a result, over time, network equipment will be able to handle more traffic as a result of that.
Are there going to be issues with removing that checksum? Is it there for a safety reason or just there for verification?
Well, the reason why it was even there is that early networking was very unreliable. So it was doubtful that you'd get a nice error-free transmission of anything most of the time. And that's classic how Ethernet developed, is that you assume the worst and it works just through sheer dumb luck. Now, stuff is a lot more reliable today than it used to be. So that type of error or packet loss.
The checksum is there to make sure that all the packets are from the same group and pre-order them?
No, it just protects the header.
Huh.
So just make sure the address and the ordering hasn't changed. Like from bit errors. It doesn't protect against malicious tampering. So the intention when the IPv6
So it's
group
only a protection against it being destroyed in transmission?
From layer 1 issues.
yes.
It's like the barcode with the UPS you ship. The barcode should stay so they can quickly check to make sure it's still going to the same place.
Yeah, it doesn't
They
say
don't
anything
care
about
what
the contents of the
box.
package. Yeah. Now with v6, the assumption is that your lower link layers will provide enough error correction, or you're running some sort of protocol on top that will also provide that, like TCP, that will also provide error correction or detection for your packets. So they said, okay, there's redundancy here, there's redundancy in each of the 3 layers, let's just take it out of here and save us a lot of headache. One of the interesting things that you run into with an IPv6 once you start deploying it is the sheer number of addresses has interesting side effects. So today you'll have the 3 dotted notation, sorry, the 4 dotted notation for an address. That would be really painful to write if you had to write that for 8 bits on a 128-bit address. So they actually went to hexadecimal notation, and you would end up writing an address like that, depending on what the bits are set to. So F0 hex is the equivalent of one of these, of one of your octets. The double dot means there's nothing but zeros in between, and then 1. Now, typically any address you'll see will be longer than. I'll show you some once I pull up the laptop. But it's not as painful to write as it seems, considering how big the numbering actually is. The other interesting thing from a numbering allocation point of view, if you remember old school networking from 10 plus years ago, there are things called class networks, A, B, C, and these corresponded to a /8, a /16, and a /24. That's how many bits was in the address portion of the field. So an A network, this number was the network, and then the rest of this was the actual device numbering. With IPv6, the smallest network that you can route is what's known as a /64 network. So that means half your bits are dedicated to the network and half your bits are dedicated to the device. Which, coincidentally, a /64 could hold the entire internet today by raised to the 2nd power. So you're never going to run out of devices. And this allows you to play a lot more games.
So that seems really wasteful. Why are they so wasteful with their addressing?
Didn't they learn from IPv4?
Oh, you have so many frickin' addresses, it's not even worthwhile to ration.
5 megabytes, you'll never use that much space.
18 quintillion addresses in.
1 for every 2 square inches of land on Earth?
More than that.
I thought it was something like that.
Way more than that.
Way more.
It's like for 1 million addresses for every star in the universe or something like that.
Yes.
And you'll never use IP between the stars because of the speed of light.
Actually, the interesting thing is,
Well,
okay, so /64 is the
would,
smallest network you
but
can
not
have.
TCP.
A normal ISP will probably assign out what's called a /43, which allows you 65,000/64 networks to your home. That is the current numbering policy recommendation by IANA. Now, notable other, huh?
More IPs.
Yes, and tons of networks. Now, the biggest requested network on record at the moment is the U.S. Department of Defense. They asked for a /13 and got it, and can't even count that high. How many zeros that's going to be? I can pull up the number, but it's an absolutely ridiculous amount of addressing. Now, granted, with IPv4, the DoD did have their own Class A, and then some, so that's kind of par for the course for them.
So how do you do broadcast?
That's a good question. There is no broadcast in IPv6. They got rid of it. What they did do is, in IPv4, multicast was optional, and most people didn't implement it. So in IPv6, multicast is mandatory. So instead of having a broadcast address, there's a local multicast group that the switches and devices join, and that's what substitutes for broadcast. And I don't remember what the address of it is off the top of my head. I think it's 27.1, something like that, or 270. You can find it if you hit it Wikipedia. And that leads to some interesting other things about how the network gets configured on IPv6. So on IPv4, you hook up a device. Typically, the first thing you end up doing with a client is you hit your DHCP server and say, give me an address. What should I be numbered as? You don't have to use, there is DHCP for IPv6, but it's not required. Instead, what ends up happening on your local network is, so you have your switch and you connect to it, and when the device connects, it uses that multicast group and listens for router advertisements. So what the router does, every so often, it sends out a packet saying, this is what your auto configuration information should be. And the device picks its own IP address based off of it.
How frequently is every so often?
I can look it up. It's every
Well,
couple
are we
seconds.
talking like once every 10 minutes or
It's every
once?
couple seconds. Now, with that auto configuration, so since a /64 is your smallest one, a device will pick a random number and